In the previous lecture, we discussed some examples based on inverse Laplace transform, and in this presentation, we are going to have one more example based on inverse Laplace transform. So let's get started. We have discussed the case number 1 of partial fractions in which the denominator of f of s have real and distinct roots. And now in this presentation, we are going to discuss the case number 2 of partial fractions in which the denominator of f of s have real and repeating roots. And we will discuss it with the help of one example. And the example is given as: find the inverse Laplace transform of f of s is equal to 2 over s plus 1 multiplied with s plus 2 whole squared. Now we can observe in this particular case that the roots of denominator of f of s are real and repeating. And this is the case number 2 of partial fractions, and we will solve it by splitting these two terms as two different fractions. So moving on to the solution, we are given f of s is equal to 2 over s plus 1 multiplied with s plus 2 whole squared, and by partial fractions it can be written as a over s plus 1 plus b over s plus 2 plus c over s plus 2 whole squared. Now we can observe that we have three different fractions due to the presence of real and repeating roots. And now we need to find out the values of a, b and c. Let us find out the value of a in the step number 1. We have s plus 1 as the factor here, so to isolate the value of a, we need to multiply s plus 1 on both the sides. So multiplying s plus 1 on both the sides, we will get 2 over s plus 2 whole squared is equal to a plus b multiplied s plus 1 over s plus 2 plus c multiplied s plus 1 over s plus 2 whole squared. In this way, we have isolated a. Now, if I put s is equal to minus 1, then this factor and this factor will become 0, and we will get the value of a is equal to 2. So we are done with the calculation of a, and we will now find out the values of b and c. We are having s plus 2 in the denominator of b, and to isolate the value of b, we need to multiply s plus 2 on both the sides. But we cannot find out the value of b by substituting s is equal to minus 2, because we also have one factor s plus 2 in the denominator of c when we will multiply s plus 2 on both the sides. And if we substitute s is equal to minus 2, then this factor will become undefined. So we cannot find out the values of b or c by substituting the value of s is equal to minus 2. So we need to try with some different values of s to find out the values of b and c. If we take the value of s is equal to 0, then we will have 2 over 4 is equal to 2 over 1 plus b over 2 plus c over 4. We have already calculated the value of a, so we have substituted the value of a in this equation, and if we solve this equation, we will get 2b plus c is equal to minus 6. Similarly, if I substitute the value of s is equal to 1 in this equation, then we will get 2 over 18 is equal to 2 over 2 plus b over 3 plus c over 9. And if we solve this equation, we will get 3b plus c is equal to minus 8. Now we have two variables and two equations. If I subtract this equation from this equation, we will get the value of b is equal to minus 2. And if I substitute the value of b in this equation, we will get c is equal to minus 2. So now we are done with the calculation of a, b and c, and we will now put all these values in this equation, and we will get f of s is equal to 2 over s plus 1 minus 2 over s plus 2 minus 2 over s plus 2 whole squared. Now we can apply the inverse Laplace transform on f of s because we know the inverse Laplace transforms of these three factors. So we will have f of t is equal to the inverse Laplace transform of this function minus the inverse Laplace transform of this function minus the inverse Laplace transform of this function. So what is the inverse Laplace transform of 2 over s plus 1? Yes, we know it is 2 multiplied e to the power minus t ut. Ut is multiplied with e to the power minus t because we are dealing with unilateral Laplace transform. Similarly, what is the inverse Laplace transform of 2 over s plus 2? Yes, it will be 2 multiplied e to the power minus 2t ut. And now we need to calculate the inverse Laplace transform of 2 over s plus 2 whole squared. And we can easily calculate the inverse Laplace transform by using the frequency shifting property. We have discussed one example based on this property in the previous lecture. If I assume one function as 1 over s square, then the inverse Laplace transform of 1 over s square will be equal to t. And if there is shifting in the frequency domain, then the exponential function is multiplied to the function in the time domain. So we can have the inverse Laplace transform as minus 2t multiplied e to the power minus 2t u of t. So t is the inverse Laplace transform of 1 over s square, and e to the power minus 2t is the exponential function which is multiplied due to the shifting by a factor of 2 on the left hand side. We have ut common in these three factors, so we can take out the ut as common and we will have f of t is equal to 2 e to the power minus t minus 2 e to the power minus 2t minus 2t e to the power minus 2t multiplied with u of t. And this is the inverse Laplace transform of the function f of s. And we have calculated this by the use of partial fractions. Try these questions on your own and post the answers in the comment section. I'll end this lecture here. See you in the next one.